In this video, I'm going to start to look at vector operations. In particular, I'm going to consider vector addition, vector subtraction, and scalar multiplication. And as I do these, I'll talk about both the geometric and the algebraic definitions of each. Let's start with vector addition with the geometric interpretation of this. There are two different rules for vector addition. They are both equivalent, and so it really just depends on which one you prefer. The first rule is the parallelogram rule. In this case, we need to start with two vectors whose initial point coincides. And I'll call these vectors u and v. So the idea is the two vectors form adjacent sides of a parallelogram. So first, I'm going to continue by drawing out the rest of this parallelogram. And then once I do that, I can then draw the diagonal of this parallelogram. And the diagonal is going to be u plus v. So the sum is the diagonal of the parallelogram whose sides are determined by the two vectors. We can also define vector addition using what's known as the triangle rule. For the parallelogram rule, we needed the initial points of the vectors to coincide. But here, the initial point of one should be the terminal point of the other. So as an example, here's a vector u and a vector v. The initial point of vector v is the terminal point of vector u. In this case, we would draw the other side of the triangle, and this would be u plus v. So this is the triangle rule, is we make the initial point of one the terminal point of the other, and then we draw the third side of the triangle to get the sum. Next, let's look at the algebraic interpretation. So while the geometric interpretation is great if we are thinking about vectors in terms of arrows, most of the time we think of vectors as in terms of a point, where the arrow is drawn from the origin to the point. So let's suppose we have two vectors, u, which is given by u1, u2, u3, etc., all the way up to un, and then v, which is v1, v2, etc., up to vn. In this case, if I want to add the two vectors, I add things that are in corresponding positions. So I add u1 plus v1 to get the first entry. The second one would be u2 plus v2, etc., all the way up to un plus vn. So let's look at an example of this. Let's suppose we have two vectors. U is the vector 1, 2, 4, and v is the vector 2, negative 3, 1. In this case, if we want to do u plus v, we would do 1 plus 2 for the first entry. The second entry would be 2 plus negative 3. The third entry, 4 plus 1. So u plus v is given by 3, negative 1, 5. Next, let's look at vector subtraction. To start with vector subtraction, I need to start by defining the negative of a vector. So if I have a vector u, the vector negative u has the same length as u. However, it's in the opposite direction. It's the direct opposite direction. So if I want to talk about something like v minus u, what we really want is v plus negative u. So let's look at how this relates to our parallelogram rule as well as our triangle rule. Here I have a vector v and a vector u, and I want to determine the subtraction v minus u using my parallelogram rule. So what this means is v plus negative u. So first I need to take this u vector and move it to the opposite direction. So here I have negative u. And from there I can draw out my parallelogram. And then I can take the diagonal of that parallelogram, this one here, And this would be v minus u. For the triangle rule, instead of making the terminal point of one the initial point of the other, we're going to have them both have the same initial point. And if we want to find v minus u, we have our arrow go from u to the tip of v. And that would be v minus u. So we're going to make the arrow go from the terminal point of the one we want to subtract to the terminal point of the one we are subtracting from. What about the algebraic interpretation? Let's suppose we have two vectors, u and v. U is given by u1, u2, etc. up to un, and v is v1, v2, etc. up to vn. In this case, we subtract corresponding positions. So we would do v1 minus u1, v2 minus u2, etc. So let's look at an example. Let's suppose u is given by 1, 4, negative 3, v is given by 2, 2, 1. And in this case, I want to find u minus v. So I'm going to subtract 1 minus 2 for the first entry, 4 minus 2 for the second, negative 3 minus 1 for the third. So u minus v is given by negative 1, 2, negative 4. The final operation we're going to look at is scalar multiplication, and this is multiplying a vector and a number. So what we're going to do is multiply a number like k times a vector like u. So just a regular lowercase letter is going to be a scalar, which is just a real number. And the idea of this geometrically is it keeps the direction of the vector but changes its length. As an example, let's consider this vector here, which is u. 1/2 u would then cut the length of the vector in half. Negative u would change the direction of the vector. It would keep the length, but it would move the arrow to the opposite end. 2 times u would double the length of the vector. Negative 3u would make the vector 3 times as long and in the opposite direction. Next, let's look at the algebraic interpretation of this. Let's suppose we have a vector u given by u1, u2, etc. up to un. Then ku would be ku1, ku2, etc. through kun. So we would multiply each entry by that number. So let's look at an example. Let's let u be the vector negative 3, 2, 5. And I want to find 2u. Well, that would be 2 times negative 3, 2 times 2, and 2 times 5. And if we simplify that, we get negative 6, 4, 10.